Take my phone. I'm going to show you our little house. As you can probably see, let me try to zoom out. There are a lot of boxes in here for a bathroom. If you do not know, this is the bathroom space that I had to work on with two other classmates of mine. There's some stuff over there for switches, and there's even a fan for ventilation. But basically, this bathroom is to what a standard bathroom code would look like. We had to measure those for the, what is it called, awning for like your sink. They're not the tallest they should be, but they're where they have to be for what our purposes were. And then over here are some switches and primary power income from your panel. These basically just draw all the power you would need for what I would say is your bathroom power. It comes out of this one, primary power, if I'm recording. It comes out of this one, and these are just switches. And basically, these also run down here to this box, and that box just jumps over to that box. Sorry once again, someone else is talking in the video. Thank you. Continuing on. In this segment, I kind of just ramble on about how I had to run 3 wires through the joists to the breaker box, but I feel that that is kind of useless, so I will just say a few things. First of all, what I base this project off of is called the NEC, that is the Electrician's Bible. It tells us all of the codes and requirements that an electrician needs to abide by to have a sustainable house, and an inspector needs to clarify. So if an inspector came into this building that we have in our lab, they would say that we did an okay job according to code because we were drilled that we were to follow code, and that's it. Well, now I'm back, so I have 2 things. In my left hand right now, I have a conduit bender. In my right hand, I have a piece of conduit. What? Basically metal piping. Oh, so what this is used for is basically to protect your wire. So when you're in a commercial setting, you can have a bunch of things happening, like moving forklifts, a bunch of heavy boxes or things moving around. This just protects your wire. So right now, it is bent into a 90, and a 90 basically just helps you get around corners. I don't have a surface that I can mount this on right now, but I can sort of show you off to the side on something. So, point of a 90 is to go around a bend at a 90-degree angle. So, your 90, you can see there's a square right here. It would go around, and this is not perfect 90, but as you can see, it would go around and hopefully just come out straight on the other side. This is probably not the best example, but this is just a piece of conduit we had laying around that was in a 90. So that's a 90. It's probably one of the most common bends that we do, besides a box offset. I'll show you that in a second. So right now, since I'm going to try to save some conduit, I'm just going to turn this around. Currently, if you want to look, there are a bunch of symbols on here, if you can see. I don't know if you can. Over here, there's a little star around here. That's where you want to put it. Somewhere around here. Oh wait, it's over here. So there's a little thing. That's where you're going to line up your mark on your conduit. Generally, you want to have a mark on your conduit because you're doing specific lengths, but right now it does not matter. I'm going to back up so you can sort of see this. So, first you want to put your conduit in, and you want to make sure it's lined up. And you want to... At this point, the video had to be cut off because there was cutting in the background, but furthermore, in like 10 seconds, video would be put back on because it stopped cutting. So, here's this little snippet of my voice. And then on the other side, you're going to want to move a little bit.
I moved away from the table for a reason, so. Hold on, let me grab my safety glasses. Alright, let you guys get your safety glasses on.
You have a random ass too.
And that's sort of a box offset. Box offsets really are just about 15 to 30 degree back-to-back bends.
Focus, I got a blue.
Can't really see it in that. I have to do a more drastic one. Once again, there is cutting in the background, so I had to mute it again. But this is getting towards the end of the conduit section as I bend this offset, and I will show you a proper example of an offset in a second. That's slightly better. Once again, I had to mute the video because of cutting, but here is an example of a box offset. As you can see, there are two black marks. That is where you do your bends in your bender, and it goes into the box with a little clamp right there. You can also see the red arrow points to it, but that is all a box offset really is. For this section, I kind of just ramble on again about it, so I'm just going to voice over it. So to start off, this is a motor control circuit. It is a real simple one. I probably say it's a complex one in the video, but it is really not. It's pretty simple. I might even show a ladder diagram for it later, but I digress. So it is an on-off circuit. It starts and stops, basically, and you can see the motor starter. It kind of flicks on and off with the coil. It's really cool. And then those are chips, and that's a CR. The CR basically is a giant switch, essentially. It's a giant magnetic switch. When you get power to it, it turns on and off. So if I can focus my camera, there is a diagram for it. It basically tells you how the CR works, and I will include a diagram at the end of what a CR circuit looks like. And that's pretty much it for motor control. This is probably my favorite thing to do because it's a giant circuit and running wire. But yeah, that's about it. Thank you. And lastly, here is a CR. There are 8 pins in this one. As you can see, 2 and 7 are your primary power for this. It goes into 2 and comes out of 7. That basically controls your coil. 1 and 8 are your main primary closed contacts for 4 and 5. And then your open contacts are 1 to 3 and 8 to 6. Basically, that just allows you to have some fancy switches turn on and off different circuits depending if the coil is getting power. So say if I were to power 2 and 7, that would turn 1 to go to 3 and 8 to go to 6, because now the coil has power and it just flips those. It's just a fancy switch, and that's all there is to it. And for this last section, I decided let's show some high voltage electricity. So here is a Jacob's ladder at 2,200 volts.
Holy hot too.
In the clip before, you probably heard some vibrating. That is the result of high transference of electricity from path to ground. That just means that there is a big ground fault. In this instance, you can see the white flash arc that is over my classmate's arm. That is basically what happens when you have a giant ouchie in a circuit. Currently, this is running at 2,200 volts, so it's a pretty high rating, but it is not the worst it has been. There are bigger ones called arc flashes, and that is the danger that comes with working with high voltage electricity. But yeah, that is the end of my senior project, and thank you for watching.